Hello everyone. In the video today we're going to talk about TrigSub. So first thing we need to know is when to use it. And here I've listed the two identities. One of them is just rearranged that give us a hint to use trig substitution. So notice that we know this one the other way around, where sine squared theta plus cosine squared theta equals 1. But if we rewrite that, we'll get 1 minus sine squared theta equals cosine squared theta. And that means if we see something like 1 minus x squared or a squared minus x squared in a problem, in an integral, then we'll choose x equals sine, because it will fit this identity, and then we can replace the whole thing with cosine squared theta. Same idea here. Tan squared theta plus 1 equals secant squared theta. So if you see an x squared plus 1, or 1 plus x squared, or x squared plus a squared, or a squared plus x squared, you'll know to use x equals tangent so that you can get these two terms to be replaced by one term, secant squared theta. And then the last possibility we have is when we have x squared minus 1, which looks like secant squared theta minus 1 equals tangent squared theta. So if you see an x squared minus 1 or an x squared minus a squared, then you know to use x equals secant theta. Okay, when not to use. So you're going to not use TrigSub whenever any other method works, because TrigSub is usually the longest and most challenging of our integration techniques. It's easy to make a mistake. So why would you not use TrigSub for the following integrals? Let's look at number 1, 4x over square root x squared minus 1. Well, for this, you could do u sub. You could just say u equals x squared minus 1, du is 2x, and then solve it from there instead. What about number 2, x squared over 4 minus x squared? This one, partial fractions is definitely better. 4 minus x squared is factorable, and it is a polynomial on the bottom. You would just have to do long division first, because the power of the top is equal to the power of the bottom, the degrees. And then this last one, 2 over root 1 minus x squared. Why would you not do TrigSub there? Because this is just an antiderivative that we should recognize. You could put the 2 outside, then it's just 1 over square root 1 minus x squared. So speaking of which, here's a bunch of stuff I would like you to memorize. The derivative of the antiderivative of 1 over a squared plus x squared, and the antiderivative of 1 over square root a squared minus x squared are ones that are going to show up quite a bit. And you can do TrigSub with these if you want. It's just going to, or you can do u substitution, but you have to factor out the a, and it's a little bit confusing. So I'd prefer if we just memorize these antiderivatives. Likewise, with these antiderivatives of regular trig functions of sine, cosine, tangent, secant, cosecant, cotangent, you can pause the video, so I'm just going to leave this up for like 2 seconds and then move on. And then the identities, the Pythagorean identities. I dropped the cosecant, cotangent one because it doesn't really show up enough. And then we know these half angle ones, and then the double angle one for sine. All right, let's do some practice in choosing our functions. If we have an integral like this, we want to know what is the substitution we're going to make. Which trig function are we going to choose? So in this case, we see 25 minus x squared. That's making me think of 1 minus sine squared theta. So that'll be x equals sine theta, and then a 5 in front, so that when we square it, we get 25 minus 25 sine squared theta. And whenever we say what x is, we're also going to find dx. In this case, 5 cosine theta d theta. Next one, dx, integral of dx over x times x squared minus 1 to the power 3 over 2. So this one is TrigSub for sure. Nothing else is going to work. We can't do partial fractions because of this exponent of 3 over 2. It needs to be an integer exponent for it to be a rational function. But we see x squared minus a number. That's making me think of secant squared theta minus 1 equals tangent squared theta. So we're going to choose x equals secant theta, and dx equals secant theta tan theta d theta. Third one, integral dx over x squared times square root x squared plus 9. I see a plus in there, x squared plus 9. So that's going to be tangent. And because there's a 9 there, we'll do 3. X equals 3 tangent, dx equals 3 secant squared theta d theta. do a couple more. X squared minus 49. This is going to be 7 secant theta. And the derivative of that is 7 secant theta tan theta. Then we have 9 minus x squared. This again is going to be a sine. X equals 3 sine theta. Dx equals 7 cosine theta d theta. And then dx over 4 plus x squared. Again, this is going to be tangent because we see that plus. And the 2 comes from the square root of 4. And we'll get dx equals 2 secant squared theta d theta. Here's a challenging one. For this one, we need to complete the square. So we're going to take that 4 next to the x, divide by 2 and square it. That'll give us a 4. And since this is an expression and not an equation, we have to add it and subtract it at the same time. That's what these yellow plus 4s are. Then we're going to regroup it as x squared plus 4x plus 4 in parentheses plus 5, combining the negative 4 and the 9. And then factoring that x squared plus 4x plus 4 into x plus 2 squared. From here, I'm going to say this entire thing, x plus 2 squared, is square root 5 tan theta. We know it's going to be tangent because we see an addition sign there. And we know to put square root 5 in front because of that plus 5 at the end. From here, x plus 2 equals square root 5 tan theta. We can subtract 2 on both sides and get our value for x. X equals square root 5 tan theta minus 2. And let's take the derivative of that. Square root 5 secant squared theta. I forgot the d theta. Shame on me. Okay, let's do a couple examples of drawing and applying the triangle. So here I'm just taking some of the examples we did before. We already know the substitution we're going to make is x equals 5 sine theta. Let's rewrite that as sine theta equals x over 5. And we know by the definition of sine, it's the opposite side over the hypotenuse of a right triangle. So here we have theta. We're first going to label the opposite side as x, and then the hypotenuse as 5. And then use Pythagorean theorem to get the last side. So we will get square root 25 minus x squared. And this usually shows up in the original problem that we have, just with a different exponent sometimes. But here it is exactly 25 minus x squared. Cool, cool, cool. And let's just check what would secant of theta be. And I just chose these randomly. So secant theta is hypotenuse over adjacent, since it's the reciprocal of cosine. And so we'll get 5 over square root 25 minus x squared, because the hypotenuse is 5, and the adjacent is square root 25 minus x squared. Let's do another one. Here we made the substitution x equals 7 secant theta. If we're solving for secant, we'll get just x over 7. And again, the definition of secant is hypotenuse over adjacent. So we'll label the hypotenuse first as x, the adjacent as 7, and then the opposite side, using Pythagorean theorem, we'll get square root x squared minus 49. Then what is cosine theta, for example? Well, cosine is adjacent over hypotenuse, so that's just going to be a 7 over x. And the last one, we're going to take that challenging one, x equals square root 5 tan theta minus 2. Let's rewrite this by solving for tangent theta. We'll get x plus 2 over rad 5. And again, we're just going to equate the numerators and denominators here using the fact that tangent theta is opposite over adjacent. So the opposite side is x plus 2. The adjacent is square root 5. And then the hypotenuse is going to be square root of 5 squared plus x plus 2 squared, and then the square root of that. So it's going to look the same as this factored version of it, x plus 2 squared plus 5, but with a square root over it. So using that, what would cotangent of theta be? Well, cotangent is adjacent over opposite, so we'd get a rad 5 over x plus 2. If you wanted sine theta would be x plus 2 over squared, x plus 2 squared plus 5, because it's opposite over hypotenuse. Cool. We're going to run through one big example that you can look back to if you need it, and then you'll try these practice problems that are down below in the document by yourself. So we got x cubed over square root x squared plus 36. We see a plus, so we're going to do tangent, and that 36 is going to give us a 6 out front. So first thing we're going to write x equals 6 tan theta, just solving for tan theta right away for the purposes of drawing our triangle. Tan theta equals x over 6, and that's opposite over adjacent. We also want to say dx is 6 secant squared theta. So let's draw our triangle. Opposite is x, adjacent is 6, and that means the hypotenuse will be square root x squared plus 36. So when we sub in, we're just saying x equals 6 tan theta. So cubing that, we'll get the 6 cubed tan cubed theta. Dx becomes the 6 secant squared theta d theta that I have here. And then on the inside, we're replacing x in parentheses with 6 tan theta. Next, we're going to lump these 6's together to get 6 to the 4th power, and then leave the rest of the top the same. Square this, so we'll get 36 tan squared theta. Let's factor that 36 out in the bottom. And then let's apply the square root to the 36. And that'll give us a 6 in the denominator. The next step, we're going to again lump the 6's together. 6 to the 4th over 6 is 6 to the 3rd. And then we're using the identity, tan squared theta plus 1 is secant squared theta. Next, we're going to apply the square root, so that's secant theta. Then we're going to cancel one of the secant thetas, and we'll be left with 6 to the 3rd, tan cubed theta, secant theta. Okay. So we've come pretty far already. This would, if you stopped here, you probably get half credit because you did most of the work. We haven't integrated yet, which is an important part, but we've done a lot of the simplifying. So next step we're going to do here is translate these tans and secants to sines and cosines. We can try to do substitution, but we don't have enough secants to do it. We need like at least 2 to do any sort of substitution here. So instead we'll change it to sines and cosines. Sine cubed over cosine cubed, and then 1 over cosine. That'll give us a sine cubed over cosine to the 4th theta. Rewriting that here. And we're going to break that sign up, since it's an odd exponent, into an even number of signs and an odd number of signs. And then we're going to take that even number of signs and change it using the Pythagorean identity to cosines. So that'll be 1 minus cosine squared theta times sine theta. And now we're ready for a substitution. We can say u equals cosine theta and du equals negative sine theta. I forgot the d theta again. Shame on me, shame. So I forgot the d theta there. But we can make our substitution, putting a negative out front. And we'll get 1 minus u squared du over u to the 4th. And if we use our exponent rules, it'll be u to the negative 4th minus u to the negative 2nd. Let's take that and integrate it. When we do, we add 1 to the exponent and then divide by that new exponent. We'll get negative 1/3 u to the negative 3rd plus u to the negative 1 plus c. And then here, I'm kind of combining a couple steps. I'm going to write the positive 1 first. So 1 over u, but back substituting at the same time with u equals cosine theta. So 1 over cosine minus 1/3 1 over cosine cubed theta. And I forgot the plus c. That's okay. It comes back at the end. Don't worry. Then we're going to change 1 over cosine to secants. And then we are going to apply our triangle. We know secant theta is hypotenuse over adjacent. So according to our triangle, hypotenuse is square root x squared plus 36, and our adjacent side is 6. So then we're just going to sub in wherever we see the entire expression secant theta. We're replacing the entire expression secant theta with square root x squared plus 36 over 6. And my plus c came back. It ran away for these 2 lines, and then it came back. And this is our final answer. You could combine the 3 and the 6, the 3rd power, and here you might get like x squared plus 36 to the 3 halves, and then over 216. But it's not totally necessary. I would be fine if you did this. We went this far and then stopped here. Okay, I hope this video was helpful. In the problems below, there's 4 of them, and each of them has the solution blacked out. Just make sure you highlight the solutions if you need them. I also put the answers at the top of the solutions, so if you want just to check your answer really quick, you can just highlight the very top. All right, I will see y'all in the next video.